Okay, so suppose we want to differentiate, say, this function x. So I have x plus 3 times x plus 2. So from the basic rule that if we have f of x is equal to x to the n, the derivative is equal to n x to the n minus 1. Now do not try to differentiate the first factor and then times or multiply that to the derivatives of the derivative of x plus 2. So this will apply for polynomial functions but not with the product of factors. So this is wrong. So just to make a note, we don't say derivative of x is 1 and then plus 0, then derivative of x plus 2 is times 1 plus 0. So this is completely wrong. But what we can do in algebra, there is a way to simplify the expression x plus 3 times x plus 2. If you want a longer way, they say, oh, I want to use the FOIL, that's multiplying the first, the outer, the inner, and the last. Some people can mentally find the product of this expression by using this idea in their head. So if I will do that, so I have x, the product of x plus 3 and x plus 2 is x squared plus 5x. 5x because I know that this is 3x and this is 2x. The sum of 3x and 2x is 5x, and then plus 6. If you're not able to follow that, we can always do the FOIL. Multiply the first and the first, the outer and the outer. So this is the outer times the outer, the inner, and then you multiply the last terms of each factor. So 3 times 2 is equal to 6. Now, since we were able to transform x plus 3 times x plus 2 into a polynomial expression, then the basic rule of differentiation will now work. So the derivative is equal to 2x plus 5, which is entirely different to the one if we had used the basic rule on each factor. Okay? Now, in this video, I'm going to show you another option in finding the derivative of expression wherein you have a product of expressions. So by the word product, the rule that I'm going to present is actually called the product rule. Now, just to introduce an expression, let's call this u, the first, and then the second as a v. So how do we differentiate the product of u and v with respect to x? The product rule says you copy the first factor, and then differentiate the second, so the v, with respect to x, and then you copy the second v, then differentiate the u with respect to x. So do not be afraid of the formula, because once I present to you how we can get the derivative of the expression, you will find it easy. Okay, so let's use this as an example. So if I have to differentiate, so find the derivative of x plus 3 and x plus 2, so I want to differentiate this with respect to x. And if I will keep in mind that this is u and this is v, the rule is just saying that the derivative is you copy the first, that's your x plus 3, and then differentiate the v. So find the derivative of v, which is basically 1, and then plus that with, this time you copy x plus 2, and then differentiate x plus 3, the u, so that is also 1. And simplify it, this is x plus 3, because x plus 3 times 1 is basically x plus 3. And x plus 2 times 1 is also x plus 2. So combining like terms, you have x and x will become 2x, numbers and numbers will become 5. and this is basically the same with what we found a while ago. Now you might say, oh, why should we even do that if we can easily simplify the expression and then apply the basic rule on differentiation. Now at this point, we still don't have, or this is still a very simple expression. Later on, when you go to other functions, you will find an expression wherein this has an exponent, say there will be an exponent 6 here, and say there is an exponent 8. And I don't think expanding this expression will be the best idea to get the derivative of the expression. Now, so this expression is already with an exponent. There is still another rule that I have to present on how to differentiate expression with exponent. So we will go to that when, or I will discuss that when I present that rule. Okay, but for now, so keep in mind that whenever you want to differentiate a product, so that's the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. Okay, so let's find another example so that you can master the idea. So let's try the rule. Say f of x is equal to 3x plus 2, and we have 5x minus 7. So the derivative is equal to the u. So this is the u. You copy and then differentiate the second factor, which is basically 5. Then add that to the second factor multiplied to the derivative of the first factor, which is 3. And then simplify it. So this will be 5 times 3x, 15x, 5 times 2 is 10, plus 3 times 5x is 15x, 3 times negative 7 is equal to minus 21. Then 15x plus 15x is 30x, 10 minus 21 is negative 11. So the derivative is equal to 30x minus 11. So that's how you use the product rule. Okay, so I hope that was able to help you. Okay, so in the next video, I'm going to show you how to use a quotient rule.